Hello everyone. Today we are talking about Model Context Protocol or MCP. It was brought forward by Anthropic to standardize the way models communicate with our own data. For those of you who don't know about the knowledge cutoff and knowledge bases for large language models, I'll give you a brief summary. Models like ChatGPT, Claude, DeepSeek, etc. cannot directly access our personal data or live data, as these systems are trained on data available on the internet only up to a particular date. Beyond this date, these models cannot give factual answers. With time, these companies train the model with the latest data, but it's not always the most updated data. If you want to make use of these models to help with our own data or the latest updates in news, or maybe things like how the stock market is performing, then we need to give access to the LLM so that it can understand the current data and derive conclusions. It can even access our own on-premise data on database to come up with the insights. If we have defined the knowledge base for these actions, then we can make use of the RAG. But if we are talking about the vast amount of data that keeps changing or fetching real-time data, then the model should have the capability to pull in the real data and make use of it. Anthropic came forward with MCP that sets a unified way through which we can provide access of data to models and would help the model to come up with better conclusions. It provides a universal open standard for communicating AI system with data sources, replacing fragmented integrations with a single protocol. This result is simpler, more reliable way to give AI systems access to the data they need. So this enables developers to build secure two-way communications between their data source and AI-powered tools. So let's see more. So they have introduced three major components for Model Context Protocol. So these are the MCP specifications and SDKs. There are Python, JavaScript, Java-based Kotlin SDKs available. The local MCP server supports Cloud Desktop app. Here we can add tools, resources to Cloud Desktop so it can make conclusions using them. An open source repository of MCP servers. And also this whole project is open sourced. Now we will be diving a little bit more deeper in and try to implement it with Cloud Desktop. If you go to cloud.ai/download, you would be able to download the desktop version for Windows or macOS. I don't think they have a version for general Linux systems. I personally use WSL to work on Windows, and I do all of my coding works with WSL. But if you want to add MCP to the cloud desktop, you need to set up the environment within Windows itself. We'll come back to that soon. Now let us shift into the documentation part of Model Context Protocol. You can go to modelcontextprotocol.io website, shows the documentation for MCP. Here you can see all the SDKs available, which are like Python SDK, Kotlin, and all of them. The general architecture for this is also very simple. So let's look into that. So we can have any number of MCP servers doing different activities. Some might be dealing with APIs, some would provide access to databases, and some would be customized tools for specific use cases. These are all hosted with MCP clients and like IDEs or Cloud Desktop in our scenario. So let's move forward. This architecture includes MCP host, MCP clients, and MCP servers. So MCP hosts are programs like the Cloud Desktop, IDEs, or AI tools that wants to access data through MCP. Protocol clients that maintains one-to-one connection with these servers, and the MCP servers are those lightweight programs that each expose specific capabilities through the standardized Model Context Protocol. So there are two data sources. One is local data source and remote services. Local data sources are usually those things which are within your on-premise, mostly small databases, files, or everything within your computer or laptop. Remote services include external APIs or anything you can connect through internet. That is the remote services.
These are the list of apps that supports MCP. You can have a look at them. These include Cloud Desktop, BAI, and many other applications. You can read out the whole example clients documentation to have a better idea about this. This is Python SDK for MCP. You can check on this if you're a Python developer. You can install this using the UV command or with the pip command. For those of you who don't know about UV, it is an alternative to pip that handles things using a pyproject.toml file and has a much better terminal interface. I suggest everyone to use UV instead of pip. Try it out, see if you like it. If you like it, try to maintain it, or else you can switch back to pip. So here is a quick start script on MCP server. So like I mentioned, you need to install all these things on Windows. You can run the MCP server by the command mentioned over here, and there is a lot of example script even in the home readme itself, and if you go deeper into the codes, you can see many other examples. It supports images as well. And let's scroll down and let's go to the section of MCP primitives. So there are like 3 primitives, which are prompts, resources, and tools. MCP can use tools or prompts, like when we want to use very specific prompt in certain scenario. By adding these into the MCP, users would be able to pick up these prompts and use them in specific cases. There are many other examples and even different ways to run the MCP server. Now we are switching back to the first example, which is the simplest one, and I'm going to show the process of adding a tool to Cloud Desktop. So we have a resource, we have a tool which is add. So I changed the add function to add alpha. Actually, I kept the add function, added another function called as add alpha. What it does is it maps a relation between numbers and alphabets. And also note that I have given the name of the MCP server to be alpha2. Okay, here you can see the mapping of A to J, A to 1, and J to 0, and all the in-between digits mapped to alphabets. So there is the add alpha function, which takes in a strings and takes in 2 strings and gives output as an integer. So what it does is it decodes the input alphabets into numbers. So if I'm giving as ABC plus, let's say AJ maybe, okay. So ABC will be decoded to 123. Okay, and AJ will be decoded to 1 and 0. That is 10. So ideally, if we ask the Cloud Desktop to add ABC plus AB, it should come up with an answer of 123 plus 10, which is 133. So after this, I'm going to test it with both Cloud Desktop. First, I'm going to add it into Cloud Desktop. Then I'm going to check it with Cloud Desktop and Cloud Web App. So this is the logic behind this function, and the LLM has to have the logic when to call this function based on the user question, then execute the function, get the answer, and display the answer in the front end. So this is what the LLM model has to do. So as you can see, I have 2 functions in total, add alpha and add. So if you go to Cloud Desktop and press on the hamburger menu and settings into the developers, you will be able to see the place where the MCPs are being added. So it's right now empty, and I'm going to add our MCP into this. So like I mentioned, we need to use, you can use a command prompt or a PowerShell. I'm going to go with the command prompt in order to add this. I have done environment and things are installed in that environment. So I ran MCP install server.py. So it states that added server alpha 2 to cloud config, successfully installed alpha 2 in cloud app. So it should have now been added to the cloud app. Let's go ahead and check. So you can see that two MCP tools are available over there, which is add and add alpha, which was within the alpha 2 server. You can go to the hamburger menu, the settings, and check for the developer, and you will be able to see the alpha 2. And you can click on edit config, a file will pop up, and in that you will be able to see the configuration. If you add in more servers, then it will add as a new key within MCP servers. So this is about the MCP, and let's now go ahead test it out. So what I'm going to do right now is keep the cloud desktop on left and keep the cloud web app on the right. And I'm going to paste the same question on both of these. Both of them are using Cloud 3.7 Sonnet. So the question is, what is ABC plus HA? Give only the answer. So I added in, and I'm doing on both. On the left one, which is the desktop, it is asking for allow tool from alpha 2, and I'm going to allow it for this chat. On the right hand side, it has already created the answer, which is A into BC plus J, which is actually correct because it is ABC plus AJ, but it does not give out any output. So on the left side, you can see that the output is 133 as we have calculated in the codes. So this is how the whole MCP thing works, and gradually I believe in every model we would be able to use these protocols, not even just in the desktop app, maybe in the web app as well. This is just a small example of MCP protocol in action. In the GitHub repository for the Python SDK, you can find other examples. There is a weather example which is connected to news API. You can see it over here, api.weather.go, and has alerts and other features. You could try it out yourself or start building new agents with MCP protocol. I hope you gained a good understanding of MCP during this session. Thank you for watching, and subscribe for more.